All right, and we are live. Hey, everybody. Welcome to Cloudy with a Chance of Learning for today, where we're going to talk all about tsunamis.
It should be an interesting topic, right, Andrew?
Yeah, it should be. It's again one of those things that's kind of steps away from meteorology, and it talks a little bit more about what's happening around our Earth. And I'm pulling up Facebook now, by the
Exactly.
way, Megan.
So,
We're going to be answering some questions from people as they come in.
okay, good deal. And you were talking about meteorology and tsunamis, but we'll be getting into if meteorology impacts tsunamis. So,
That's
if
right.
weather can generate tsunamis too.
That's right. The weather can generate tsunamis sometime as well. We're going to be talking all about that too. So, guys, go ahead and bring us your questions. We'll be happy to answer them for you. Again, this Cloudy with a Chance of Learning is all about tsunamis. So, let's jump into it. Go ahead and take it away, Megan.
Yeah, so when we're talking about a tsunami, they're typically defined as a large ocean wave, usually caused by an underwater earthquake.
Yeah, so those earthquakes occur whenever plates will hit together or rub up against each other, possibly. These plates are within the Earth's crust. So, in the Earth's crust, when it's under the ocean, if they collide, that can actually cause the water to rise up above it, and then we have the beginning of what could be a tsunami.
Exactly. So you can see multiple impacts with tsunamis, like storm surge. Think about that with storm surge from a hurricane, it causes the coastal flooding. That's going to be a major impact with storm surge. Now, with tsunamis, kind of the same thing. The main impacts with it are coastal flooding. This could also be caused by volcanic eruptions. That's one thing that could also generate a tsunami. Now, tsunamis, they do range in size. They can go from inches to over 100 feet. So think about that. Just this large wall of water. It's kind of slow motion, especially once it approaches, not only shallow water close to land, but also just shallow water in general.
Yeah, and Megan, let me turn you up just a little bit. I'm having trouble hearing you. All right, so yeah, it can be a large wave, or it could even be a little bit on the smaller side. As the waves travel inland, they can get higher and higher as depth of the ocean decreases. So, kind of similar to storm surge there. How if you have a shallow depth of the ocean, you can get a big storm surge.
Exactly. And as waves travel inland, they can get higher and higher as depth of the ocean decreases. So that's something to definitely remember there.
Yeah, and Megan, let me turn you down actually a little bit. I've got you turned down a little out here. All right, sorry about
All
that,
right, we should
everybody.
be good to go.
Yeah, y'all ask your questions that you may have. Send them our way. We'll love to answer them for you. Oh, you know what? I clicked ahead. Hold up 1 second. So, wave height can increase over 10 times as tsunamis spread over shallow water. So that's pretty impressive.
Yeah, and some of you are wondering how fast do tsunamis move. So again, it depends on the depth of the water. So remember this, the deeper the water, the faster the tsunami. So the deeper the water, the faster the tsunami.
Yes. So, with that being said, Megan, how fast do these typically move?
So advanced. They can actually move, tsunamis can move as fast as a jet plane, up to 500 miles per hour. So very fast speeds there. Of course, it's going to depend on the depth of water and how fast they move, but there have been tsunamis that have been as fast as a jet plane, which is over 500 miles per hour. Now, they can cross oceans in less than a day. So think about all that mileage. Tsunamis move so quickly that they can also cross oceans in less than a day, less than 24 hours. So that's just crazy to me.
Oh yeah, and it depends on the depth of the ocean too, right? For their speed. I think we had that on our last graphic.
Right. So the depth of the water definitely matters. The deeper the water, the faster the tsunami.
Wow, that's amazing. So they can cross oceans in less than a day. They slow down as they approach shallow water near land. I guess that would be good if you wanted a little bit more of a warning. At least you may kind of see it coming, right? Is it easier to kind of see them coming?
Exactly. So when you're looking at a tsunami, the way it appears is think about a wall of water. So that's kind of a way to look at it. Like we've talked about, they range in size, so they could be, inches, which is very minor, versus feet, hundreds of feet. So that's something to look out for, and also just pay attention to the natural warnings. Scientists are still studying earthquakes and also tsunamis altogether. So I know we have the U.S. tsunami warning system. So what they'll do, and this is a part of the National Weather Service, what they'll do is the scientists behind issuing the warnings, they'll actually pinpoint if a tsunami is currently happening, and then they'll issue warnings for those inland. So if it were to impact a coastal area, they would issue warnings for those areas. And you're probably wondering, where tsunamis are mostly found. Well, 78% of tsunamis occur in the Pacific Ocean. Mainly around the Ring of Fire, if you've ever heard of that area.
Wow. And so some of these can occur, though, in the Atlantic and Caribbean Sea as well.
Exactly.
So that's about 8%. And then we also have 6% of them occurring in the Mediterranean Sea, which, by the way, is over there towards Europe and Africa, if you were wondering about geography there. And then we have about 5% occurring in the Indian Sea, which is kind of just west of India and east of Africa.
Right. So think about where the earthquakes typically occur. Remember, it's when we define a tsunami, it's a large ocean wave usually caused by an underwater earthquake. So think of all the fault lines. We were talking about the definition of an earthquake. So it makes sense that most of them are found in the Pacific Ocean.
Yeah. So most tsunamis generated off the coast of Japan, and then some other areas are like Russia and Indonesia. But what about the United States, Megan? Where do they occur typically in the
Right.
United States?
So it's yeah, there's a low chance of it developing in the Gulf Coast. We're going to talk about that here in a second. But as far as the United States, you have the U.S. West Coast, Alaska, Hawaii, Puerto Rico, and the U.S. Virgin Islands. So those are some areas where you typically see a tsunami if one were to occur.
Okay, interesting. So, and I'm not seeing many questions come in on Facebook. Guys, if you have questions, please send them our way. I see we have Addison joining us. So, Addison, welcome. We hope you're having a great day there.
Hey,
But yeah,
Addison.
so they're not as common in the Gulf. For the U.S. Gulf and then the Atlantic coast. Has there ever been one in the Gulf, though?
So there has been one in the Gulf, but it's been, several years. An earthquake off Puerto Rico back in 1918 produced the only tsunami on record for the Gulf Coast. So geography of the Gulf may reduce the impact a little bit there. I think, the main impact was a mudslide. So that was the main impact there.
Okay, interesting. And when a tsunami can happen at any time, of course. Just it depends on whenever those plates are moving and whenever there's a volcanic eruption. But can weather generate tsunamis?
So this is actually interesting, Andrew. So let's talk about that. A tsunami can happen anytime, no matter the season, no matter the weather. But here's the big question. Can weather generate tsunamis? Well, the answer is yes. Now, this is pretty rare. It's typically having to do with fast moving systems like a squall line.
Okay, so like derechos. That's something that's actually the definition of derecho here, guys, because that's a kind of interesting word, and I think we've used it in past Cloudy with a Chance of Learnings, but it's basically a long windstorm, a windstorm that has been going for a long time and moving quickly and can cause a lot of damage. I actually covered one back in Arkansas when I worked in Jonesboro, Arkansas. We had a derecho move through. But they can occur all over the place, and it's a big complex of thunderstorms with a lot of strong wind. And I guess those can cause tsunamis too. I actually didn't know that, Megan.
Right. So think of the strong winds associated with squall lines, and it all depends. We actually call these meteo tsunamis, kind of like meteorology, right?
Yeah.
So the development depends on speed, direction, and intensity of the disturbance. So of the squall line, and also as it travels over the ocean. So the speed, direction, and intensity of the disturbance as it moves over the ocean. That's going to be the key thing there.
Okay, and in June 2013, it looks like we had one. A tsunami-like waves were along New Jersey and Massachusetts coasts, and it was generated by a big derecho. I think I remember that one occurring. I was in school for weather
Hmm.
right there back in Mississippi State, and I believe I remember that one.
And it wasn't that long ago. I mean, June of 2013, it's only June of 2020, so it really wasn't that long ago. Andrew, you talked about how you've never even known about that. When I was researching about tsunamis, I didn't know that weather could generate tsunamis. So I think that's a very interesting twist there.
Yeah, but I would guess that it's kind of similar to how storm surge occurs, because with
Hmm.
hurricanes, we have water being pushed up onto land, but that's a little different with storm surge. I guess these tsunamis are from the wind pushing down on the water and causing it to create those big waves.
Right. And I think you can kind of see it a little bit too. Of course, you'll have different watches and warnings issued versus, we have the new products now of a storm surge warning. So you have the different warnings to factor into getting ready for a tsunami versus storm surge. It's also going to depend on how much water is pushed inland. So storm surge can sometimes travel a little bit, more inland versus a tsunami.
That's really interesting. Yeah, and I never really thought of it too much that way. That's really cool. So, the
Hmm.
largest earthquake ever recorded. Now, not all earthquakes cause tsunamis. It depends on where they are with water. But on May 22nd, 1960, a magnitude 9.5 earthquake off the southern coast of Chile. Remember, that's that Ring of Fire area that we were talking about in the
Hmm.
Pacific. And then that second largest earthquake, and that's in the same Ring of Fire type place, right, Megan?
Exactly. In fact, both the largest earthquake ever recorded and the second largest, both of these produced dangerous tsunamis and destructive tsunamis. So that is something to keep in mind. I mean, a 9.2 earthquake and a 9.5, that is very powerful.
Yeah, that is very powerful. We've got a few questions coming in. Addison asked what a tsunami is. Of course, Addison, we've been answering that as we've gone along. Robert says Japan has a very old written recording of a tsunami caused by Cascadia subduction, and I'm not sure what that is, Robert. I'm gonna have to look that up myself. Again, we're learning more about tsunamis ourselves. So, can a
Hmm.
hurricane cause a tsunami? That's what Stephanie's asking. And the answer is it can cause storm surge, which is a little bit different there, Stephanie. And then Jesse says, you guys are very knowledgeable, great information. No problem, Jesse. We're happy to be able to share it with you. So,
I
both
do
of
want to
those.
go back
Oh,
to
sorry. Go ahead, Megan.
Hey, Andrew, I do want to go. I know there's a bit of a delay, so it's a little tricky here. But Robert, I do want to go back to your question about the subduction zone. So that's actually why tsunamis are less common over the Gulf Coast because they're not in that zone, the subduction zone. So that's why they're more common over the Pacific Ocean, especially the Ring of Fire.
Okay. See, Megan, I wasn't
Hmm.
sure what that was about, but I'm glad you were able to answer it for him. Sometimes we got to put our minds together to get these to have the correct answer here. But yeah, man,
Yeah,
that's
and it all has
interesting.
to do with geography and plate tectonics too.
All right, Megan, I'm gonna have to hear more about this subduction zone later on. So, those two earthquakes, the largest earthquakes ever recorded, were both in the 60s, 1960 and 1964. That's, of course, before you and I were alive, Megan, but that must have been an active year for the plate tectonics, that
Exactly.
is.
Yeah, exactly. So let's kind of backtrack here. So tsunamis are a series of long waves. So who asked the question, what is a tsunami? So we
That
have
was
Jennifer
Addison.
asking. It's
It was
Addison.
Addison who's using Jennifer's account there.
Yes, so Addison, this is kind of the recap for you. So we know we have the definition on the right there too. It's a large ocean wave usually caused by an underwater earthquake. But tsunamis are a series of we're talking extremely long waves, and this is caused by a sudden displacement of the ocean. So remember that. Less of weather. I mean, weather can cause tsunamis. They can generate tsunamis over the ocean. It depends, again, on the squall line speed, direction, if it's moving over the ocean, but most of it is typically caused by geography. So think of plate tectonics. So that's that sudden displacement of the ocean that we're talking about. Going to impacts, this is important. We talk about hurricanes and knowing the impacts more than the category versus, a category 1 hurricane or a category 2 hurricane. Pay attention more to the impacts. But coastal flooding and also strong currents. So you could have, strong rip currents associated with tsunamis. And like I said, scientists, they cannot predict when and where tsunamis strike, but of course we do have the U.S. tsunami warning system, and that's tied in with the National Weather Service.
Right, and we at least know when a tsunami is coming. We just don't know when one's going to occur. It's kind of like earthquakes. You don't always know when one's going to occur. There was a big tsunami in Indonesia, and I don't remember the exact year, but we're talking maybe about 10 to 15 years ago, maybe. I don't remember the exact year, but it caused a lot of damage and even some death down towards Indonesia because the earthquake occurred and then the water just took off and covered a lot of the islands. Not completely covered, but caused the water to go well up onto shore. And then we had another one that was a little bit more recent, but still about, I would guess about 10 years ago, and that was the earthquake the tsunami in Japan. I don't know if you remember that one too, Megan, but the water just rushed inland. And again, that's in that area of the Ring of Fire where there was a lot of water pushed on shore from those earthquakes because the earthquakes are more common in these areas.
Exactly. We talked about Japan. We talked about Russia and Indonesia. Alaska is another place if we're talking about the United States. So it's definitely something to watch for. Again, the U.S. Tsunami Warning System, they pinpoint where there's currently a tsunami. So we have buoys to help us with wave heights and all of that. And what's interesting too, I'm sure you could see them on satellite maybe in some areas.
I'm sure you could as
Depending
well.
on the wave height, of course.
Yeah, you would probably be able to see them. It's just you'd have to have a really good satellite with really good imagery to be able to see it, though.
Right, right. So different kinds. So they pinpoint where that tsunami is, and then they issue the warnings.
Yeah. All right. Well, hey, guys. Well, that was all about tsunamis. I don't see any more questions coming in. Addison says she loves us. Thank you so much. Erica says, can you predict when the tectonic plates are going to move? And I think they have a way to get an idea of the tension on the plate. I'm not 100% sure on that. Again, this is a little bit away from meteorology, but I think they can get an idea on if the plate may have a lot of tension, but they can't always guess when it's going to move. That's the big thing. They have a better grasp on if a volcano is about to blow, and sometimes those underwater volcanoes can cause tsunamis as well, so that's another thing. But I think it's a little trickier to get an idea on when a plate's going to move, especially one that's underwater. I would imagine that getting sensors to those points could be a little bit more tricky, but science is always advancing. That's the thing about being a scientist, is there's so much more to learn. That's why the science is there in the first place, and it's always innovating, it's always learning, and kids at home, that is what a scientist is all about. You're always learning. You're always innovating. And Megan, I'm speaking for both of us here. I mean, we both are always doing that ourselves as meteorologists.
Exactly. It's so important to come up with new ideas just so you can make forecasting better. You can make a more advanced warning system. That's something that we always talk about out in the meteorologist community. So those are just a few examples there.
Yeah, being a scientist is fun. It can be frustrating because there's always that big challenge. There's a big challenge. But it's almost like working on a million-piece puzzle and just putting pieces on as you find them and trying to make sure that that's right. And sometimes you put a piece in and it didn't fit right, and you're like, well, I'm just going to have to figure out what this is over time. So let's take a look at cloudy with a chance of learning in the schedule. Megan, it's looking like we have a fun week ahead of us. We got tropical funnel clouds that we're going to cover tomorrow. I'm going to be working a little bit on some graphics for that myself today, and it should be a fun topic because we had some tropical funnels on Friday last week that led to some tornado warnings in southern Bee and southern Live Oak counties.
Oh, wow.
Yeah, so it's more typical along the Gulf Coast. We'll talk more about it tomorrow. I don't want to give it all away right now, but we'll talk more about it tomorrow. It should be a lot of fun. On Wednesday, we're doing a field trip to the Museum. Guys, if you missed our field trip to the San Antonio Zoo on Friday, we got to learn all about giraffes, and it was a ton of fun. The giraffes joined us for the entire Cloudy with a Chance of Learning lesson. Go back on YouTube, watch last Friday's lesson. It was so much fun. Please watch it. It's going to make your day. You can also see it on Facebook, but sometimes they're a little bit easier to find when they're there on YouTube. So we're doing a field trip to the museum on Wednesday. And by the way, we're not done with our field trips to the zoo. We're going to learn about more animals coming up on this Friday. We're doing another field trip to the San Antonio Zoo. We had so much fun last week, and I can't wait to see what they have for us as we move into Friday this week. And then Thursday, what is CAPE? That's convective available potential energy. So that's what CAPE stands for, and we're going to learn all about that on Thursday.
And there's going to be a quiz, right, on what CAPE stands for, because you gave it away.
That's right, I gave it away. You're going to have to remember CAPE stands for something there. So guys, we hope you have a wonderful rest of your day. We're going to go ahead and sign off here. Again, that was all about tsunamis. Don't forget, we're going to continue to do Cloudy with a Chance of Learning all throughout this summer, all throughout July. This is not going anywhere. We love being able to teach y'all all about all these different weather topics and sometimes even about space. Megan, you always do such a great job putting these graphics together and explaining things. Sometimes about tsunamis, your space graphics. I love that lesson on space, and I know you enjoy doing it as well.
Oh, I love space. And going back to the field trip that you were talking about last Friday with the San Antonio Zoo, my mom went back because she loves giraffes. My mom loves giraffes so much, she kept up with April the giraffe, and it's actually her phone background and her iPad background, and she just loved it. So I'll have to tell her to tune in this Friday too.
Nice, nice. Yeah, it should be a lot of fun. And, I didn't know giraffes had purple tongues. Did you know that?
I had no clue.
And did you know that giraffes can kick in any direction, not just forward? They can kick off to the right, behind them. We learned so much. You've got to go back and watch it. It's a great lesson and a ton of fun. Can't wait to have them on again this Friday and to have the museum on Wednesday. So guys, have a wonderful rest of the day. Megan, you have a great day too.
You too.
All right, and we're going to go ahead and sign off here. So have a wonderful Monday, everybody.